Hi class, this is course 3, lesson 35, and we're going to talk about similar and congruent polygons today. Couple things that you need to memorize, and you're going to read this going down. So polygons are similar if corresponding angles are the same measure or congruent and corresponding side lengths are proportional. Okay, so what does that mean? It means, first off, let's take a look at these triangles that I've sketched out here. Notice these angle markings, right? They're tick marks. You match those up. Those show congruence. So this angle is the same as this angle. And this top angle is the same as the top angle in the larger triangle. And this on the angle on the right has 3 marks, and that matches up with the ones that have the other angles that have 3 marks. So I know that all of the angles are the same measure, so they're congruent. Now, I know that they are similar if their corresponding angles are the same measure and corresponding side lengths are proportional. So we have to write a proportion with the corresponding side lengths. Now remember that similar polygons may be flipped over or upside down or rotated. You know, we can use those transformations, and we need to make sure that we match up the corresponding sides. So the side between the 1 marked angle and the 2 marked angle, those need to be proportional. So I just write a ratio, and if you go small to large or large to small, that's fine, but you have to do the same on each of the side lengths. So you might want to label like small over large, or figure 1 over figure 2, whichever way you want to label them so that you remember what you're doing. So then we would take the side lengths that are corresponding and make a ratio, and then set another ratio equal to that to make a proportion. So then the side with the 2, between the 2 and the 3 is 6, and the side between the 2 and the 3 is 12. Are those proportional? Now remember, you can test by saying, can you multiply or divide across, or look up and down. So the small one is times 2 to get to the large. This is times 2. So does that work with the other side length, 8 over 16 times 2? Yes, so these are similar polygons. Now, the other thing that you need to memorize is that polygons are congruent if the corresponding angles are the same measure and the corresponding side lengths are the same. Okay, so compare the two processes to identify whether we have similar or congruent. In both cases, the corresponding angles have to be congruent. They have to be the same measure. So this is the same. It's the side lengths where, if they're going to be congruent, that means they're equal. They're the exact same excuse me, size and shape. So in order for that to happen, your side lengths that correspond to each other need to be the same length, whereas in similar polygons they just have to be proportional. So here are 2 congruent triangles. Excuse me. Notice that they're rotated a little here. I have one angle that corresponds with this one. This one is 3, so it corresponds with the 3. This one is 2, so they correspond. And I don't know if you want to draw lines on your paper to show which ones go together or make a note. And when you have the number of tick marks, like a 1 corresponds with a 1, 2 corresponds with 2, 3 corresponds with 3. Okay, so hopefully, because all the side lengths are marked and they correspond to each other, and the angles that correspond to each other are congruent, then we have congruent figure. Okay, a couple other things that you need to memorize. These are specific to triangles. Okay, so these other rules back here work for polygons, any polygon. These work only for triangles. Side, 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 triangle similarity. If the corresponding side lengths are proportional, your triangles are similar. So this one bypasses the angles altogether, right? It's saying if we know that the corresponding side lengths are proportional, then we have similar triangles. Also, angle, angle, angle triangle similarity, and this is S, 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 and this would be A, A, A. We're getting the S from side, 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 and the A from angle, angle, angle. If the corresponding angles are congruent, the triangles are similar and the side lengths are proportional. Okay, so just a different way of looking at how you can say that you have similar triangles. You need to know these, and you'll refer back to these quite frequently. Okay, one other thing is scale factor. So we've addressed scale, that's the dilation, but scale factor has no units. So if you're given different units, you need to convert to one or the other and then simplify. And here's an example. A map is drawn with 1 inch representing 6 feet. What is the scale factor from the map to the actual area? Okay, so from the map is 1 inch to the actual area would be 6 feet. Okay, and this is fine, but it's not right, because you either need inches over inches or feet over feet. And then you're going to divide out those units. Divide out units and simplify. Okay, so let's do this conversion. I like having the number 1 in the numerator, so I'm going to convert 6 feet to inches. So 12 inches in 1 foot, so there are 72 inches in those 6 feet. So I would write this as 1 inch equals 72 inches, which then divides out those inches, and it's already in simplest form. So you can write this as 1 to 72. Now if you do, that's a scale. If you do anything with models or cars, like Matchbox cars, you'll see the 1 colon number, and that will tell you what the scale is. Okay, so that's our scale, right? Our scale factor, as long as this is 1, is 72. Scale factor. And what that means is that's the number that you multiply times whatever inches there are to get the actual inches in real life. So if I had 2 inches on my paper, I could multiply that times 72 to get 144 inches, which then I would probably convert to 12 feet. And you might say, okay, so why didn't I just use 1 to 6? Well, if you have 1.5 inches, 1.5 inches, that might be a little less clear when you multiply that you have 9 feet. Okay, this is how it works. Scale factor will not have units, and it's just the number that you would multiply. Okay? Now, I know you're going to have questions. That's okay. Please ask as you're working on the problems. I will see you in class.